Hello everyone, I am Dr. Rajesh and I welcome you in this video lecture. In this video lecture we will study a Gauss forward interpolation formula, and we shall know that this formula is used when the interpolating value lies in the middle of the table. Like we are given that we are given values at 1 and say 10 to 15 we are given, 15 to 20, 20 to 25 and 25 to 30, 30 to 35. Okay, and frequency is given corresponding say 5, 10, 15, 25, 30, something like that. This is frequency. We are asked to find the value at 23. So 23 in the middle of the table. So for that we will be using Gauss forward interpolation formula when interpolating value lies in the middle of the table, in the center of the table. So this formula is also known as central difference formula. Fine. So Gauss forward interpolation formula is a central difference formula. So we will be doing its proof by Newton forward interpolation formula. By Newton's forward interpolation formula, we know that y is equal to y naught plus u by 1 factorial delta y naught plus u minus 1 by 2 factorial delta square y naught u minus 1 u minus 2 by 3 factorial delta cube y naught plus u minus 1 u minus 2 u minus 3 divided by 4 factorial delta 4 y naught plus and so on. So this is the Newton forward interpolation formula. So we will write it in the some compact notation form y naught, and this is written in subscript form u subscript 1, and this is written as u subscript 2, this is written as u subscript 3, and this is written as u subscript 4. Fine. So this is where we should mention the meaning of subscript. U subscript r is equal to u minus 1, u minus 2 up to u minus r minus 1, 1 less, divided by r factorial. This is equal to u minus 1, u minus 2 up to u, open this minus, it will be minus r plus 1 divided by r factorial. Fine. Where r is, we are starting from 1, 2, 3 and something like, so it will be r is 1, 2, 3 and 3 dots. Fine. Which is ellipse. These three dots are known as ellipses. So now name this equation as equation 1. After, in Gauss forward interpolation formula, after first two terms we diminish the subscript of y by 1. So diminishing means decrease, diminishing the subscript of y, subscript of y by 1 in equation 1 after first two terms, after first two terms. Fine. So now we will be diminishing the subscript. Fine. This is delta square y naught, this is delta cube. So if we have to diminish any nth order forward operator, say it is y naught, so here should be -1, because it is diminishing of 0 by 1 is -1. So this will be, by definition, this will be forward operator of n plus 1 order and -1. So from here we can calculate the value of delta n y naught. This will go over there, this will be delta n plus 1 y minus 1 plus delta n y minus 1, where you have to mention, you have to diminish the subscript of this after two terms 1 and 2. So after first two terms, so here delta is square, so here n is equal to 2, you have to mention n is 2, n is 3, 4 and so on. Fine. So you can calculate these, all these value, put n is equal to 2, you will get this one, n is equal to 3. So using this in equation 1 we get, and also mention that after first two terms, after first two terms. Okay, so here we will put up the value. This will be y is equal to y naught plus first two terms is to be written as such, delta y naught plus u2 will be as such, and instead of this one I am going to substitute this thing for n is equal to 2. So it will be delta 3 y minus 1 plus delta square y minus 1 plus, now you will write u3 as such, u3 will be as such, and in the braces you will write n is equal to 3, it will be delta 4 y minus 1 plus delta 3 y minus 1, close it, and this as such, u4 and n is equal to 4, put it over here, delta 5 y minus 1 plus delta 4 y minus 1 plus 3 dots. This will go on something like that. Now collect the terms. This is delta cube, here is delta cube, so we will collect this term. Delta square is single term, so it will be written alone. Delta 4, there is delta 4. Now collecting the likewise terms, we will get y naught plus u1 delta y naught plus u2 delta square y minus 1 plus delta cube, here is also delta cube, so this will be u2 plus u3 and outside is delta cube y minus 1 plus here is delta 4, here is delta 4, it will be common, so inside we are u3 subscript u subscript 4 and outside is delta 4 y minus 1 plus similarly it will pair up with something term that will be following this one, so I am going to use 3 dots. Fine. Now we will see that this u2 plus u3 what it makes. We will see the u3 and u4 what it makes. We will try to see. Here we will be using the result that u of I plus u, and you are going to name this equation as equation number 2, u of I minus 1 is equal to u plus 1 subscript I. Okay, so I am going to show you this as a proof. You will write we know that. Okay, now we'll take the left hand side ui plus ui minus 1. So write it u minus 1, u minus 2 up to u minus I minus 1. Fine. Divided by I factorial. Fine. Plus it will be u minus 1, u minus 2 up to u minus less than 1 of I minus 1 will be I minus 2. Fine. Divided by I minus 1 factorial. So this will be u minus 1, u minus 2, u minus I plus 1 divided by I factorial plus u minus 1, u minus 2 up to u minus I plus 2 divided by I minus 1 factorial. Fine. Now you see this will be common and term preceding to this one will be u minus I minus 2, this term. So if I write one more term over here, so this will make u minus 1, u minus 2, this is diminishing by 1, so this will be u 1 preceding to this one. Yeah, what it will be, I minus 2 minus, it will minus I plus 2, so the I minus, this will be the term preceding to this one. Fine. Divided by I factorial plus u minus 1, u minus 2 up to u I plus 2 divided by I minus 1 factorial. Now take the common. What will be common? u minus 1, u minus 2 is common up to u I minus 2, u minus I plus 2, and I can be written as I into I factorial, so I minus 1 factorial, I into I minus 1 factorial, so I minus 1 factorial can be taken outside. So this will be u minus I plus 1 divided by I, it will be 1. Okay, fine. So this will be u minus 1, u minus 2 up to u minus I plus 2. This I to I will cancel out, so we are left with u plus 1 by I into I minus 1 factorial. So this can be written as u plus 1 u, and this will be u minus 1 u minus 2 up to u minus I plus 2 divided by I factorial. So this further can be written as u plus 1 u minus 1 u minus 2 up to u plus 1, and it is minus I minus 1 divided by I factorial. So this can be written as u plus 1 up to minus I minus 1. So this can be written as u plus 1 subscript I. So we have established the relation, this one, that ui plus ui minus 1 is equal to u plus 1 I. So we have established the relation. So now we will be using this relation into this one. So what it will be? It will make this term will be as such. So this will be as such, and here we will be writing what it will be by this formula, and here you will mention that you are using it for, this is 2, it is for you are using it for I is equal to 3, okay, and I is equal to 4. So here you will mention I is equal to 3, 4, 5 and 6. So this term will be nothing but u plus 1, and greater of these is 3. Fine, u plus 1 and greater of this formula, and this one will be u plus 1 and greater is 4. So now using this formula, say 3 into, we will be writing it over here using 3 into, we get y is equal to y naught plus u1 delta y naught plus u2 delta square y minus 1 plus, it will be u plus 1 subscript 3 delta cube y minus 1 plus u plus 1 4 and delta 4 y minus 1. Okay, so this we have written. You can once again confirm from here. Okay, this u plus 1 delta and something u plus 1 4. So we have written it from there. So now we'll see here. You see, when we go from here to here, it converts from 1 to 2, and simultaneously subscript is decreased. Okay, when the subscript of y remains the same, u goes from 2 to 3, and as well as plus is added, and here subscript is remaining the same, but this u plus 1 is not converted to u plus 2, otherwise it would have been converted to u plus 2. Look over here, this pattern, subscript is same, this is increased, 2 of course goes to 3, 3 of course goes to 4, that is going on. Okay, 1 goes to 2, 2 goes to 3, that is different thing. Here it is not increasing, but subscript is decreasing. But look over here, subscript remains the same, 2 goes to 3. So what will increase? This u will increase. Here this u is remaining same, subscript is decreasing. Here subscript is decreasing, u remains the same. So you have to check it. Here subscript remains the same, u has to increase. Here again subscript remains the same, u plus 1. Here this has to increase and become u plus 2, but it is not becoming. So it is remaining the same. So we cannot change it because we don't know how to change it. But we know if this u plus 1 remain the same as u plus 1, so we can diminish the subscript. Here it should be, because if it u plus 1 remains the same u plus 1, so in that case subscript should diminish. So here if it is minus 1, it should be minus 2. So here should be minus 2, y minus 2. So we should diminish the subscript of y after 1, 2, 3 and 4 terms. Look over here, 1, 2, 3 and 4 terms we have to diminish. So once again I am writing diminishing the subscript of y, and what it will be? Subscript of y in equation 4 after first 4 terms. Okay, which formula we will use? The formula we have to diminish this one. So we will be writing here delta n y minus 1, and 1 less of minus 1 is minus 2, and we know by formula this is delta n plus 1 y minus 2. Fine. So this implies that delta n y minus 1 is equal to delta n plus 1 y minus 2 plus delta n y minus 2. So I am going to use this in this, and here n will be 4 because we have to diminish from here. So n will be 4, 5, 6 and so on. Fine. So we will get y is equal to y naught plus u1 delta y naught plus u2 delta square y minus 1 plus u plus 1 3 delta 3 y minus 1 plus u plus 1 4, and it will be put over here n is equal to 1. It will be delta 5 y minus 2 plus delta 4 y minus 2, and this will go on something like that. This is further equal to y naught plus u1 delta y naught plus u2 delta square y minus 1 plus u plus 1 subscript 3 delta cube y minus 1 plus u plus 1 4, and it will be delta 4 first minus 2 plus u plus 1, and I don't need to write it because I am going to plus, okay, and so on. Now see the pattern. U is remaining same, 0 is diminished by minus 1, y is y is remaining the same, u is increased by 1. Now this is diminished by 1 and u plus 1 remaining the same, and something like that. You will continue diminishing something like that because it will also contain other terms, because I have omitted this term because that will require me to move further, but I don't want to show the further terms because the formula goes forward formula to some extent I have arrived at. So now I will stop here. So that is why I have omitted this term, because that would be requiring another diminishing, because here is u plus 1, here is, this is remaining the same, so this should diminish, so this should diminish, so that would have required another diminishing by how many terms? 1 2 3 4 5 terms. After 5 terms we are requiring another diminishing, so we have avoided it and we have written it something like that, which is the Gauss forward interpolation formula. So that's all I have from this lecture, and this question, state and prove Gauss forward interpolation formula, is very important, and I have derived it from the scratch. So I hope that you will be able to understand it. So that's all I have from this lecture, and if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.